Hello guys, this get lectures of engineering mathematics on topic get questions probability part 3 is brought to you by lecturesforfree.com. Hey guys, this is the third part of my this probability lecture series. If you haven't seen my earlier part 1 and part 2, then I will recommend you to watch that lecture also so that we can solve get questions in this lecture. Okay guys, so let's start the lecture and see some sample questions of gate. So before starting the question, I have already written some rules that I have shown in you my previous lecture. Okay, we will revise it whenever necessary. So let's see the first question. This question is asked in GATE 2007. Okay, this question is asked in 2007 GATE for 2 marks. For 2 marks. Let's see this question. An experiment consists of 2 papers. Paper 1, sorry, an examination. An examination consists of 2 papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3, that in paper 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. The probability of a student failing in both the papers is. Okay, so first of all, let's see what is given and what is asked in this question. In this question, 2 papers given and their probability of failing in papers given. So let's suppose we have let's suppose I am calling A is an event of failing in paper 1. Let's suppose A is event of failing in paper 1. Let's suppose B is an event of failing in paper 2. Failing in paper 2. Okay, so what is given to you? Probability of failing in paper 1 means probability of A is given to you is 0.3, and the second thing is given probability of failing in paper 2 means probability of B is given to you is 0.2. Okay, third thing that is given to you is given that a student has failed in paper 2, probability of failing in paper 1 means it is the probability of failing in paper 1 when it is already given that it is failed in paper 2. So what this is given is the conditional probability. Okay, so what is this conditional probability? Means it is actually the probability of failing in paper 1. So it's basically the P A when your B is given. Okay, so we will write like this: P A, then line and then B. Means it is the conditional probability of happening of A when B is given, or you can say B is happened, B is occurred. So P A line B is given. Okay, how much it is given? It is given 0.6. Okay, let's see what is being asked in this question. The probability of student failing in both the papers. Okay, both the papers means probability of failing in A as well as failing in B. So I can say probability of A into B, or I can say probability of A intersection B. Okay, so we have to calculate this. Okay, so as we can see in rule like this, as we can see here in rule number 7, as we have seen in my earlier lecture, that rule number 7, probability of A intersection B is probability of A and the probability of B line A or this. Okay, so in this question you have given this thing is given, P A line B is given. Okay, this is not given, this thing is given here, P A line B. So we will apply this formula. Probability of A intersection B will be probability of B multiplied with probability of A line B. Okay, it is conditional probability. So let's apply this formula. Okay, so we can write it. We can write it probability of A intersection B, or we can say probability of AB will be probability of B and into multiplied by. Whenever I am saying and, means it is multiply. Whenever I will say or, then we have to sum, we have to add the things. Whenever I am telling and, then we have to multiply the things. Okay. And probability of a when or given b. Okay. So we can see here, probability of b is given to you is 0.2, and probability of a line b is your 0.6. So let's multiply this 0.2 into 0.6. So here you will get 0.12. So let's see the options, in which option you are getting 0.12. So here you can see in option C you are getting 0.12. So right right option for this question is your option C. Okay. Now let's see another question. A fair dice is rolled twice, then the probability that an odd number will follow an even number is. Okay. So this question is asked for 1 marks. This question is asked for 1 marks in GATE 2005. Okay. So here we can see that a fair dice is rolled twice, means it is rolled twice, means 2 events are happening. So in these 2 events are not dependent on each other. Why it is not dependent? Because whatever number we will get in our second event is not depending on the what number we will get in our first event. Okay, we are throwing a dice. So in the first time we are getting some number, it will not affect whatever it will not affect the if you are throwing dice for the second time. So these 2 events are the independent events. Okay. So what is in this question, the probability is asked that that an odd number will follow an even number. Okay, odd number will follow an even number means first time we should get odd number, and I am saying you and second time we should get the even number. Okay. So let's first of all let's find the probability of getting odd number in the first time. As we know, the in sample space of throwing a coin is like this: 1 2 3 4 5 6. Okay, there will be 6 outcomes when we are throwing a dice one time. Okay, so let's suppose we are throwing dice for the first time, then our number of outcomes in sample space will be 6. So we will get like we can write like number of outcomes in order and number of outcomes in sample space. So sample space number of outcomes will be 6. So let's find the number of outcomes when we will get the odd numbers. So here we can see 1 is the odd number, 3 is odd numbers, and 5 is odd number. So number of outcomes for odd number is 3. 1, 2 and 3. 1, 3 and 5, 3 events. So probability of getting odd number in first throw is 1 by 2. Similarly, probability of getting even number in the second time will be number of outcome for even number of outcome for even number, and the number of outcome in sample space, it will be also be the 3 by 6. Like here 2, 4 and 6, there are 3 outcomes. There are 3 outcomes where we are getting the even number, and in sample space there are 6 elements, so we will get 1 by 2. Okay, we were writing it independently because these 2 events are independent. Okay, so probability that an odd number will follow an even number will be, we can write it, probability of O dot E, or you can say probability of O odd intersection E will be probability of odd and probability of E. Okay, we are multiplying this because as we can see from rule number like this rule, in this rule when both are independent, then we can write p b oblique a or a oblique b is equal to like this, and we will get like this: p a interaction b will be p a into b or p b into a. Okay, so for independent events we can write multiply it the individual probability, and from whatever we are saying we can understand it. I am saying probability of getting odd and probability of getting even. So whenever I am telling and, then we will multiply the these two probability. So probability of getting odd is 1 by 2, and probability of getting even for second time is also 1 by 2. So our final answer will be 1 by 4. So now let's see the options. So as we can see, option D is having 1 by 4. So right option for this question will be option D. Now let's see some other question. Get questions. Suppose a fair six-sided die rolled once. If the value on the die is 1, 2 or 3, then the die is rolled for second time, and what is the probability that sum of total values that turn up is at least 6. Okay, so this question also we are rolling a die. We may roll it for one time also, we have to roll it for two time also. Okay, when we are rolling it for two time, when we will get 1, 2 or 3, here you can see whenever we will get 1, 2 or 3, then we have to roll it for the second time. Okay, so we may roll it for one time also, we may roll it for two time also. Okay, and in this question we have to find the probability that the total sum will be at least 6. Means we have to find the probability when sum will be at least 6, means we can say sum is greater than or equal to 6. Okay, sum is at least 6 means sum is greater than or equal to 6. So we for getting sum is greater than or equal to 6, we may roll it for the one time also, we may get it for one time also, we may get it for the two time also. So when we will get 6 or greater than 6 by rolling it one time, when we will get the 6 in the first time. Okay, when we will get the 6 in the first time, then only this condition will be satisfied. Okay, so probability of sum is greater than or equal to 6 will be like this: probability of getting 6 in the first time. Okay, plus, okay, plus 5 I am writing plus, means we are getting the 6 in the first time, or we may get it in the first time plus second time also. Okay, whenever we will get the second time, whenever we will get 1, 2 or 3. So we can say whenever we will get first in the 1 in the first time and 5 in the second time, then also we will get sum is equal to 6 or greater than 6. Okay, similarly we will get sum is greater than 6 when we will get 1 in the first time and 6 in the second time, then also our sum will be greater than 6. Okay, similarly we can say probability when we are getting 2 in the first time and 4 in the second time. Okay, plus we can say 2 in the first time, 5 in the second time, plus probability of 2 in the first time and 6 in the second time, then also we will get sum is greater than 6. Okay, plus we can say probability of 3 and 3, then also our sum will be greater than 6. Say greater than, not easy, it is equal to 6, then probability of 3, 4 will be greater than 6, then probability of 3, 5 will be greater than 6, plus probability of 3, 6. Okay, so whenever we will get 1, 2 or 3, then only we will get our second chance, otherwise we will not get the second chance. So other there will be no other possible combination where we will get the sum is equal to or greater than 6. Okay, so these are the only events where we can get the sum is equal to 6 or greater than 6. Okay, so here also I am telling the I am telling you the or means we are getting 6 in the first time, or we will get 1 in the first time, or 5 in the second time, or we will get. So I am telling or means we will add these all the probability. Okay, we will add all these probabilities. So let's find the this individual probability, then we will add all these things. Okay, so what is the probability of getting 6 in the first time? So whenever you are mm, rolling a die, then there are 6 possible outcomes: 1 2 3 4 5 6. Okay, so getting 6 is like getting a single number. Getting a number in the first time is like 1 upon 6. Probability will be 1 by 6. So getting 6 on the first time, probability will be 1 by 6 plus. Now here probability of 1 5. Probability of 1 5 means probability of getting 1 in the first time and probability of getting 5 in the second time. It will be like probability. Let's do it in more detail. I am writing like this: probability of 1 5. It means probability of 1 5 means you are getting probability of getting 1 in the first time, and I am telling you and means we will multiply here. Okay, multiply, and probability of getting 5 in the second time. Okay, so probability of getting 1 in the first time is like you can say 1 by 6. Probability of getting 1 or getting 2, getting 3, anything, getting any one number is like 1 by 6. Similarly, probability of getting 5 in the second time means it is also 1 by 6. Okay, probability of getting 5 is a one number, so 5 a single number means we will get probability like this, 1 by 6. So probability of getting 1 in the first time and the 5 in the second time will be 1 upon 36. Okay, similarly probability of getting 1 6 will be probability of getting 1 6 will be also probability of getting 1 in the first time and probability of getting 6 in the second time. So probability of getting 1 in the first time will be 1 by 6. Probability of getting 6 in the second time will be 1 by 6. So we will get 1 by 36. Similarly, for other cases also we will get same. We will get same like 1 by 36, 1 by 36, 1 by 36. So for this all these cases 1 5, 1 6, 2 4, 2 5, we will get the probability of 1 by 36. So there are total 1 2 3 4 5 6 7 8 9. There are total 9 cases. So we can write it like this. We can write it like this: plus 9 into 1 by 36. Okay, so our total probability will be 1 by 6 plus 9 by 36 means we will get it like 36. 6 plus 9 means 15. 15 upon 36. So all probability will be 5 by 12. Okay, so now let's see the options. So as we can see in option B, we are getting 5 by 12. So our right answer will be option B. Okay, let's see some more question. A single die is thrown twice, then what is the probability of probability that sum is neither 8 or nor 9? Okay, in this question also your die is we are throwing the die in twice means twice, we are throwing the time twice, but in this case the probability asked is not is depending on the both the both the throw. It will depend on the first time also as well as second time. So these two events are, you can say, not independent, because whatever the probability is asked is depend on both the events. Means it depends on throwing for the first time and throwing for the second time also, because sum of getting 8 or getting 9 is depend on the both the numbers, whatever we are getting in the first time and whatever we are getting in the second time. So this is, in this case, this throwing two times is considered as a single event. Okay, these two are not two different events. We are assume it is like a single event. Okay, so let's solve this question. So to solve this question, first of all, let's consider what is our sample space. First of all, let's see what is our sample space. So we are considering throwing two time as a sample space. So our sample space will be like this. Let's suppose we are getting 1 in the first time and getting 1 in the second time. Similarly, we are getting 1 in the first time, getting 2 in the second time. Similarly, 1 in the first time, 3 in the second time, like this, and we will get 1 in the first time, 6 in the second time. Similarly, you will write it like 2 in the first time, 1 in the second time, 2 in the first time, 2 in the second time. Similarly, 2 in the first time, 6 in the second time. Similarly, we can write it like 6 in the first time and 1 in the second time, 6 in the first time, 2 in the second time, and we can write it 6 in the first time and 6 in the second time. So this will be our sample space. Okay, so let's suppose so let's count how many outcomes it has. Like we can count it 1 2 3 4, like 6. This is 6 and this is also 6 and this is also 6. So 6 6 ja 36. So there are totally 36 elements in this sample space. Okay, so to calculate those events where the where the sum is neither 8 or not nor 9, it is easy to calculate the events where the sum is either 8 or 9. Okay, so let's calculate the events where the sum is either 8 or 9. Then we can calculate by applying the rules what will be the probability of where the sum will be neither 8 or nor 9. Okay, so let's suppose first calculate the event. Let's suppose I am calling it event A. Event A is like event of getting sum is either 8 or 9. Okay, so let's see here and let's see where we can get sum is either 8 or 9. So we can get 8 when we like this. In this we cannot get 8. Okay, and we cannot get sum is 8 or 9. Okay, in this we can get like where the first we will get 2 in the first time and a 6 in the second time, then we will get sum is equal to 8. Okay, in this. Similarly, so let's write the events. Let's write the events where the sum will be either 8 or 9. So we can write it like where we will get 2 in the first time, 6 in the second time. Similarly, we can write 3 in the first time, 5 in the second time, then our sum will be 8. Then 3 in the first time and 6 in the second time, then we will get sum is equal to 9. Here we will get sum is equal to 8. Okay, similarly we can write 4 4, we will get sum is equal to 8. We can write 4 5, sum will be 9. We can write 5 3, sum will be 8. We can write 5 4, sum will be 9. Okay, we can write 6 2, sum will be 8. We can write 6 3, sum will be 9. Okay, so these are the only possible things, possible events. Okay, so let's count what is the number of possible events. 1 2 3 4 5 6 7 8 9. So there are totally 9 outcomes where our sum will be either 8 or 9. Okay, so what will be probability that our sum will be either 8 or 9 will be number of outcomes in our event divided by number of outcomes in our sample space. So it will be like 9 upon 36, or you can say 1 by 4. Okay, so but in question it is not asked that what will be probability of getting sum either 8 or 9. In question it is asked what is the probability that sum is neither 8 nor 9. So to calculate neither 8 or nor 9, we have to calculate the complement of this event. Okay, so how we can complement? By using this rule, by using, as we have seen in our earlier rule, like this. Complement of any event is 1 minus probability of that event. So let's calculate it. 1 minus probability of that event. So our final answer will be PA bar will be 1 minus PA, means 1 minus 1 by 4, means it will be 3 by 4. This will be your final answer. So let's see the options. So here you can see in option D we are getting 3 by 4. So right option will be option D. Okay, let's see one more question. A fair coin is tossed till a head appears in first time. Okay, then the probability that the number of required tosses is odd is. Okay, so a fair coin is tossed till the head appears, means we will toss the coin. So it may appear in the first time, head may appear in the first time, head may appear in the second time, head may appear in the third time. So we have to calculate the probability that the number of tosses required should be odd, means we should get head in either first attempt or third attempt or fifth attempt. Okay, in odd attempts. Okay, uh, so this question is asked for 2 marks. Okay, in 2012. Okay, so to calculate this, let's understand. Question is asked is probability of number of tosses required should be required. It should be required is odd. Okay, means number of tosses, it may be 1, 3 or 5 or 7. Okay, so here I am telling number of tosses maybe 1 or 3 or 3 or 5. Whenever I am telling or, means we have to add the probabilities. So we can write it like probability of getting head in the first attempt, or probability of getting head in the third attempt, or probability of getting head in the fifth attempt. Okay, like we can write like this. Okay, so we have to calculate the each probability, and then we will add all the probabilities, then we will get the final probability. So let's find out P1. P1 means I am telling P1 means we will get head in first toss. Okay, so when we are tossing a coin, then what will be probability that we will get head in the first attempt? Definitely it will be 1 by 2. Okay, because there are only two outcomes in sample space, head or tail. Okay, so probability of getting head is half, and probability of getting tail is also half. Okay, so probability of getting head in the first toss will be 1 by 2. Okay, now calculate P3. P3 will be what? P3 is probability of getting head in the third attempt. So probability of getting head in third attempt means in first attempt you got tail. Okay, in second attempt also you got tail, and in third attempt you got head. Okay, so what is the probability that you will get here also let's pay attention. I am telling probability of you got tell in first attempt, and I am telling and it's that's why I am multiplying here, and probability of and getting tail in second attempt, and probability of getting head in third attempt. I am telling and, that's why I am multiplying the probabilities. Okay, whenever I will tell or, then I will add the probabilities. Okay, so let's keep it in mind whenever you are telling and whenever you are telling or. Okay, so probability of getting tail in the first attempt will be like 1 by 2. Okay, probability of getting head or getting tail, it will be equal, and both will be 1 by 2. So it will be 1 by 2. Similarly, probability of getting tail in second attempt, it will also be 1 by 2. And the probability of getting head in third attempt, it will also be 1 by 2. So you will get 1 by 2 to the power 3, or you can say 1 by 8. Similarly, P5. P5 will be, it means probability of getting head in the fifth attempt. Okay, for the first time, means you are getting the first time head in the fifth attempt. So you can write it probability like in first attempt you got tail, and in second attempt you got tail, in third attempt you also got tail, fourth attempt also you got tail, in fifth attempt you got head. Okay, so what is the probability of getting tail in the first attempt? 1 by 2. Second attempt is getting tail, 1 by 2. Third attempt 1 by 2. Fourth attempt 1 by 2. Fifth attempt probability of getting head, it is also 1 by 2. So you can write it 1 by 2 to the power 5, or you can write it 1 by 32. Okay. Similarly, if I will say what will be the probability of P7. P7 means probability of getting head in the 7th attempt first time. So you can observe it and you can directly write it 1 by 2 to the power 7. Okay. So let's calculate the final probability. What will be our final probability? Final probability will be P1 plus P3 plus P5 plus P7, like this. Okay, so let's calculate the final probability. Well, final probability P of let's suppose it's PA. Okay, it will be like P1 plus P3 plus P5 plus P7. Okay, plus dash till infinite. Okay, so probability of 1 is 1 by 2. Probability of P3 is 1 by 2 to the power 3. Probability of P5 is 1 by 2 to the power 5 plus dash means 1 by 2 plus 1 by 8 plus 1 by 32 plus. Okay, so here we can see this is a series. And which type of series? This is the geometrical series. Geometrical series. Okay, this is a geometrical series, and this series is converging. Why converging? Because it's 1 by 2, then it is reducing 1 by 8, then it is again reducing 1 by 32. So this series is converging. And here our first element means A is 1 by 2, and our R, okay, R will be means this factor means R will be like 1 by 8 divided by 1 by 2, means R will be 1 by 4. Okay, so we can calculate the sum up to infinity of any infinite geometrical series by using this formula A upon 1 minus R. Okay, so what is A? A is your 1 by 2, and 1 minus R. What is R? R is 1 by 4. So here you will get 1 by 2 divided by 3 by 4, means you will get 2 by 3. This will be your final answer. So let's see the options. So 2 by 3. So as we can see here, in option C, we are getting the 2 by 3. So the right option for this question will be option C. Okay guys, so thank you guys for watching this lecture, and subscribe my channel. And these are the some sample questions. If you want to see more solved questions, then you can download my handwritten notes from my website lecturesforfree.com. And you can ask me any question in my comment box in and in my website also. Thank you so much, guys.